Hello and welcome to our Chapter 2 lecture video discussion. Now, due to the size of the content for Chapter 2, I will be doing a three-part series video discussion. The first part of our video discussion is going to look at descriptive statistics for qualitative variables. In the second video, we will look at descriptive statistics for quantitative variables, and then we will end our discussion on Chapter 2 with descriptive statistics for two-way tables. Now, so far in this course, we've learned how to define statistics. We've said that in statistics, our goal is to learn from data. Now, the big question is, where does the data come from? The data are basically raw facts on individual characteristics. And so if our goal is to study about people living, say, in a certain community, we look at a certain characteristic of interest, say their age, their income levels, the hours they study, the hours they exercise, their weight, their height. So we choose a variable of interest on those people. We collect raw data on that variable of interest, and then we learn from it. Descriptive statistics is all about using different ways to summarize the data. In our first instance, we're going to learn how we can use visual tools like bar chart and histogram to describe or to summarize and present our information about a certain data set. And so the first thing we're going to do here is we're going to learn how we can summarize data for categorical variables. Now remember, we've already defined categorical variables are variables that contain values we cannot perform arithmetic operations on. And so for summarizing variables that are considered to be categorical, the first thing we need to do is to create what we call a frequency distribution. A frequency distribution basically is a table of our data, and on that table we show the name of the categorical variable and then the number of individuals belonging to that categorical variable. Let's start with a very simple example here. Let's try to create a frequency of count distribution table for favorite soft drink. So to provide a little bit of context to this, let's say I have a number of friends and I say, hey, let's order soft drinks. But then the question is, what soft drink do you want? And so for my number of friends who participated in this study, each and every one of them has their favorite soft drink. Now, if I present this information in their raw state, it becomes a little bit difficult. So let's say I'm calling my favorite soft drink joint, like Pizza Hut, and I'm gonna order favorite soft drinks for my friends. If I present it this way, it becomes a little bit difficult for whoever is taking the order. But then if I summarize it in a table form, using the frequency of count distribution table, it becomes a bit more easier for the person taking the order. So let's first of all learn how to create the frequency of count, which is one way to summarize our categorical variable data. And then we will learn how to visually represent that. And you will see that there is a clear difference between when the data is in this raw form like this, when it is in a table form, and when it has been visualized on a bar graph. And so you will notice that we have different category of favorite drinks. We have Pepsi, we have Coca-Cola, we have Sprite, and then another Pepsi and Pepsi. So on our distribution table, we're first gonna start with the first category. The first category is Pepsi. The big question though is, how many of our participants said they like Pepsi? And so we can count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of our participants said they like Pepsi. And so the frequency for those who said they like Pepsi is 9. Then we go on to the next category, which is Coca-Cola. The next question is, how many of our participants said they like Coca-Cola? So in this case, we have one, and then we have another one here, and then in the third one, 4 and 5, 6. And so our count for Coca-Cola is 6. So we do the same for all the other soft drink. We count the frequency for Sprite. We count the frequency for Dr. Pepper. Now, when you look at your frequency distribution table, you will notice that in this form, it's a bit more easier and it's a bit more understandable to know that Pepsi has the highest frequency and Coca-Cola is the lowest. I'm sorry, Dr. Pepper has a higher frequency, Coca-Cola has the lowest frequency. So this format is a bit more easier and a bit more understandable to present. Now we can go ahead and calculate the total for our distribution table. And you will notice that when we add up these, which will be equal to 20 here and then 15, so a total of 35. When we add that, the different frequency for the different soft drink, it should be equal to the total of our raw data set here. And that proves that we have accounted for every single value in our data set. Now, the next thing we can do is to calculate what we call the relative frequency. The relative frequency basically is looking at what proportion of our soft drink is Pepsi. What proportion of the soft drink is Coca-Cola? What proportion of the soft drink is Sprite? And what proportion of the soft drink is Dr. Pepper? And so in relative frequency, what we're going to do is we're going to divide each frequency by the total. And so to calculate the relative frequency for Pepsi, our formula will be to divide the 9 count of those who said they like Pepsi by the total of 35. And that should give us 0.26. To find the relative frequency for Coca-Cola, we divide the total count of 6 individuals who said they like Coca-Cola by the total number of soft drinks, which is 35. And so we do the same for all the other categories, and we should be able to arrive at their relative frequency or their proportion. Now, when you add up your relative frequency, they should always be equal to 1.0. And so I always advise that when you calculate relative frequencies, round them up to 2 decimal places, and you will be able to get the exact value of 1.0. Now, if we are able to find the relative proportion for each of the frequencies accounted for the soft drinks, we can go ahead and calculate their percent frequency. The percent frequency formula is to take your relative frequency for each class and then divide it by the total times 100. So technically, percent frequency is basically taking your relative frequency right? It's basically taking your relative frequency value and multiplying it by 100. So in the case of favorite soft drink example, as we've seen here we have the frequencies. Here we find the relative frequencies by dividing each of these frequencies by the total of 35 to get our relative frequencies. And our percent frequency is just basically multiplying our relative frequency values by 100. And so when I multiply all these by 100, I get their percent equivalent. And I'm pretty sure you may have done this in your Math 145 or any of your prerequisite math courses for this course. Now, once we're able to create our percent frequencies, we can just go ahead and visualize this using a bar graph. And so then the big question is, what is a bar graph? A bar graph basically is a graphical display depicting or showing the categorical data summarized in either their frequencies, relative frequencies, or their percent frequencies. As a statistician, you decide whether you want to use the frequency distribution to depict your bar graph or your percent frequencies. Now, in some cases, somebody may also want to just go ahead and use the relative frequencies. But at the end of the day, you should know that your categories will be on this side here, and so the different favorite drink categories will be down here, and then to the right or on the y-axis, we will have their either percent frequency or relative frequency or frequency distribution. Now, in their raw state, it's a bit more difficult to understand. The table makes it a bit easier to look at a comparison of the frequencies using percentages or the count, but the graph makes it a bit more presentable. Now, it's important to know that every graphical display should have a title. This is like a big no in statistics. If you do not have a title, the whole thing is just a waste of time because the individual looking at your graphical representation need to understand what this whole data is about, what this whole graph is about. So always make sure you have your title, you have your x-axis label, you have your y-axis label. Now, once we present the count or the percent frequency in this format, it's a bit more easier to understand and a bit more presentable as well. So from our graph, we can easily know that Dr. Pepper has the highest in terms of those who said it's their favorite drink, and the least favorite drink is Coca-Cola. Now, just know this is just for an example's sake. It does not reflect on my personal preference. Now, another way we can also represent our bar graph is to use what we call a Pareto diagram. I'm never going to ask you to define it, but basically a Pareto diagram is when we arrange the bars on our bar graph in a specific order. We could either go with descending order, which means from the highest to the lowest, or we could go with ascending order. So when we change it into its ascending form, it's still a Pareto diagram. So here we have an example of a situation where we rearrange the bars for our favorite soft drink in a Pareto appearance. The highest being Dr. Pepper using descending form and the lowest being Coca-Cola. Now somebody might also want to rearrange in ascending order. Again, another way to represent our categorical data is to use a pie chart. Now, it's very important to understand that when it comes to the two data set, the two variable types, we have categorical variables, and then we have numerical variables. Now, quick question. What is another name for categorical variables? Good. Qualitative variables. And another name for numerical variable? Quantitative variables. Now, when you have to depict your categorical or qualitative variables using a graph, we always at the basic level encourage you to use the bar graph or the pie chart or the dot chart. Now, of course, at the advanced level, you may be introduced to different ways of visualizing your graph. But these are the three we recommend at the basic level. For your quantitative variables, we have the histogram, which is another good way to visualize your quantitative variables. We have the stem plot, and we will look at both histogram and stem plot in our next video. And then we have scatter plot, which will be discussed in the last video. So these are the two variable types, and these are the graphs used to visualize them. Now, I always encourage you to use a bar graph when you're looking at the count of the frequency distribution. But if you're looking at percentage, if you're looking at representing your graph or your categorical data set using percentage frequencies, I will always encourage you to use the pie chart. Now, dot chart can be used just like you use a bar graph, and we'll look at that as well. And so, pie chart gives us another way to depict our categorical variables. Now, in our example here, where we looked at the different subdrinks and their frequency count, as well as their percentage count, for a pie chart, I would definitely look at the percentage distribution as you've seen it depicted here. So for each category of favorite soft drink, we have their percentage distribution. The pie chart basically helps us easily compare it in terms of the visual size. So Dr. Pepper, which has the highest visual size of 34%, clearly is bigger than the Coca-Cola, which has the smallest percentage. So pie charts are not the best way to visualize. Some people may think compared to bar chart, but I always encourage that go with pie chart if you have to visualize percentages. Now, the last type of visual representation is the dot plot. A very simple graphical way to represent your categorical data set. Dot plots may look like this. And so again, we could have our one variable like soft drink, and then we could have the count on the other side here. For each of the soft drink categories, like Coca-Cola or Pepsi or Dr. Pepper, right? Or the last one, which is Sprite. We can use a dot chart as that, and I think there is an example where I have something of that type. So you could have something like that, and that's how you make a dot plot. Now I'd like you to pause the video and try your hands on this simple practice question here. In this example, what we are trying to do is we're trying to create a frequency, a relative frequency, and a percent frequency of count distribution table. And so we are looking at individuals traveling from Prince George, and we are asking ourselves, what is your favorite traveling destination? If you are traveling from Prince George to some other place in Canada, which place would you like to travel to? For the individuals that we talked to, some said they would like to travel to Vancouver, some said they would like to travel to Toronto, some opted for Montreal, and some people also opted for Terrace. And so we're looking at basically 4 different categories. And I would like you to look at the data set here and create a frequency, a relative frequency, and a percent frequency distribution for that.